Hi everyone. So in this video, we're going to talk about ARP, the Address Resolution Protocol. So let's try to understand why we need ARP in the first place. What is the use case? Let's say you have two hosts, host 1 and host 2. This can be any PC or any servers which want to talk with each other. Now they are connected with a network which can consist of routers or switches or hub, or they can be directly connected. Now, host 1 has got some IP, let's say 10.1.1.1/24. And host 2 also has got some IP. It can be an IP in the same subnet, which is the case what we're seeing right now on the screen, or it can be an IP address in a different subnet. For example, 20.1.1.20/24. Now, when host 1 wants to talk with host 2, it has the IP address, the destination IP address, which is, let's say, 10.1.1.20. However, there is one more piece of information which is missing right now in order for host 1 to send the packets to host 2. And what is that? In order to understand what is that information, we need to look at the OSI model or the TCP/IP model. So in order to form the complete packet, whenever a host wants to send some packet out, in order to form the complete packet, in addition to the IP address, it needs one more information, which is what? For example, right now, if you see 10.1.1.20, it is the destination IP, the IP of host 2. Okay. Now that belongs to layer 3, the network layer. It would need the layer 2 information, which is the data link layer address or the MAC address of this particular IP address, which is 10.1.1.20. This is where ARP, Address Resolution Protocol, comes into picture. What it does is, if you have the IP address, the ARP protocol helps in getting the MAC address corresponding to this IP address. Now, how it does that? It makes use of two kinds of frames, the ARP Request and ARP Reply. Now, what are these? So here we have host 1 and host 2. Host 1 wants to send a packet to host 2, which has the IP address 10.1.1.20. So host 1, if it does not have the MAC address information of this IP address, it sends the ARP request, which is broadcast. So this is how the frame would look like. This is the Wireshark capture, which I'm going to demonstrate in a few minutes as well. So here, if you see the source, if you look at the Ethernet headers, the layer 2 headers, the source would be the MAC address of host 1, and the destination would be a broadcast, which is all F. So if you see FFFFF, total 48 bits for MAC address, so this would be a broadcast address. Now we understand that ARP is a pure layer 2 protocol. So where exactly it puts the IP address, because IP address 10.1.1.20 belongs to layer 3, but it won't have the layer 3 header because ARP is pure layer 2 protocol. So it puts this IP address 10.1.1.20 as a target IP address in the ARP payload. This is very important to understand because many people confuse that 10.1.1.20 would go as another layer 3 header, which is not the case because ARP is pure layer 2. Where this information, IP address information, will be present, it will be present as a payload on top of the Ethernet headers. Okay. So if you see the target IP address here, 10.1.1.20, that is the IP address for which I need the MAC address. Now what would happen? Now all the PCs which belong to the same broadcast domain would receive this ARP request because it has the destination MAC address as all F. Now they would decapsulate this frame. So once they remove the header, they would look at the ARP payload, and then they would see what is the target IP address. It is 10.1.1.20. Now only the PC whose IP matches this target IP address, which is 10.1.1.20, only that PC is going to send the ARP reply. So this is how the ARP reply would look like. So here, if you source would be PC host 2 in this case, which has the IP 10.1.1.20, and it would send it to the destination, which is host 1. What means? It means the ARP reply is going to be unicast. So with this, host 1 is going to get the information that, okay, for this particular IP 10.1.1.20, this is the MAC address, and it's going to populate that in its ARP cache. And once it has the information, it is going to send the messages, let's say ping messages. Now let's see this in the lab. Here I have set up a very small lab in order to understand this. So here we have PC1, which has this IP 10.1.1.1/24, and we have PC2. They both are in the same subnet. They are connected via hub. Now, if I look at both the PCs, PC1 and PC2, so PC1, if you see on the Ethernet 0, I have configured this IP address 10.1.1.1 here. And then on PC2, I have the IP address 10.1.1.20. And now on PC1, if I see the ARP cache, which I can see using IP neighbor, it's empty right now. It means it does not have the MAC address for PC2's IP if it wants to send some packet to PC2. Similarly, if I see on PC2, its ARP cache is empty as well. Now let's do one thing. Let's go to GNS3, which is here, and let's start the packet capture on this link. Let me give the name demo1. Okay, and let's do a ping from, sorry, PC1 to PC2. PC1, it has the ARP cache empty right now. What we would do is let me send out 3 packets from PC1 to PC2 whose IP is 10.1.1.20. And let's see what happens. Okay, so it has sent the 3 packets, and it has got a response as well, which means ping has been successful. Now, if I see the ARP cache, this is what you see right now. So for this particular IP, it has the MAC address table. It has the MAC address in the ARP table populated right now. Similarly, if you see on the PC2, whose ARP cache was empty sometime before, now because it has got the packet from PC1, it would populate its ARP cache with PC1's info as well. So if you see here, this is the IP address of PC1, and this is the MAC address of PC1. Let's verify if it is the MAC address of PC1 or not. So it ends with FFFE. So here, if I look at the ETH0, it's ending with FFFE. Yeah, so this is the MAC address of PC1. So it means this is how the ARP works. So if I look at the packet capture, this is what I was telling. So the first frame is the ARP request, which is the broadcast. If you see here, this is all F, and in the target, in the payload, you would see the target IP is 10.1.1.20. So it would go to that, to all the hosts which are present in the broadcast domain, and only the host which has this IP 10.1.1.20, which is host 2 in this case, would reply. It would be a unicast. This is the ARP reply, which is unicast back to host 1. And that's how the ARP helps in getting the MAC address for a an IP address. This is about the hosts which are in the same subnet. It works slightly different if the host is in a different subnet. So what it does is, instead of ARPing for the end host, it would send an ARP message for the default gateway, which we'll be discussing in another video. So that's it for this video. Thank you so much.